Hey, sorry, I gotta restart this because got interrupted there. So back to 21. I just got partway through 22. That's why I'm backing up to here. And decided that we needed to do long division here to try to simplify this into something that we could do integration with. So how did I know to do that? Well, on the bottom here, this is only x minus 2. It's not like some other factors. So it's not integration by partial fraction decomposition. And I can't divide the terms through because this is a binomial. It's two terms like separated by addition or subtraction. So I can't simplify it in that way. And you know, what else are you going to try? So I did this division. You could do synthetic division, and I turned it into this, and then that was an easy integral to find. It turned out to be A. All right. This one here, this is, if you think about what's going on here, what you would like to be true, hopefully you're thinking a little bit about the harmonic series and if this, how does this compare to the harmonic series? And you know that taking the natural log of numbers makes them smaller. So it's true that the natural log of n plus 1 is in fact less than n for all numbers greater than 1, 1 included, greater than or equal to 1, because the natural log of 2 is, that's less than e, so that is less than 1, and gets even more true after that. So if you take this inequality, the fact that the natural log of n plus 1 is less than n, and you flip these numbers over, then that means that the natural log, 1 over the natural log of n plus 1 is greater than 1 over n, right? And so if you've got a series, like the harmonic series, the sum of 1 over n, which is equal to 1 plus 1/2 plus 1/3 plus and so on, and then you have another series that's 1 over the natural log of n plus 1, so that's 1 over natural log 2 plus 1 over natural log 3 plus 1 over natural log 4, and so on. And what we have demonstrated here is that every single time this is greater, this is bigger, and if all of these are bigger and this diverges, then this has to diverge also, because every single term is bigger than this other series that also diverges. So it diverges by comparison with that. Just a quick note that this is just comparing two series. This is just by comparison. This is not limit comparison. That's a little bit different. That's when we set up that ratio and say, oh, highest power, same. So it's a little different than that. The length of the curve. A length of a curve in regular old y equals function of x form is from wherever to wherever, 0 to 3 pi over 4 in this case, of 1 plus dy dx squared dx. That's just a thing you need to know. No formula sheet for calculus. Kind of a drag, huh? So that sine x, the derivative of that is cosine x, so that's going to be the square root of 1 plus cosine squared x dx. That is d. But boy, if you know that formula, that is a real easy get right there. Let f be a function such that f prime of x is equal to this, and f of 0 is equal to 0. What are the first three non-zero terms of the Maclaurin series? Well, this is an easy series to make. I feel like we did it earlier in this set of multiple choice, didn't we? So that sine the series is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on. So sine of x squared is x squared minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial, and so on. And then if you want to, this is f prime, So if you wanted to get back to f, then you'd have to take the antiderivative of this. So that would be x cubed over 3 minus x to the 7th over 7 times 3 factorial, and so on. I'm not going to try to simplify those. And f of 0 is equal to 0. So no first term, no constant or anything. So I guess I just need to figure out which one of these second terms is right. That's 7 times 6 is 42. So that's 24 is D. Ooh, polar area. Okay. Polar curves r equals 1 minus cosine theta and r equals 1 plus cosine theta are shown in the figure above. Probably it would be helpful to figure out which one is which. So r is equal to 1 minus cosine theta. So the when you're looking at the angle 0, then this one is going to, the cosine of 0 is 1, so the r will be equal to 1. And that's not super helpful because it looks like they both go through there. This one, r is equal to 1 plus cosine theta. When you plug in 0, you get 2. So that's got to be this one. Right? Okay. Which of the following expression gives the total area of the shaded region? Well, if I start looking here, so this is this one. So if I start looking at 0 and I look up to, it looks like pi over 2. So is it true that when I plug in pi over 2 I get like 1 or something? So the cosine of pi over 2 is 0. So yes, indeed. So if I just start looking this way, I'm really thinking polar here, right? If I just start looking like that, then I could just take 4 of those. I'm going to have to choose something that matches up to one of their answers. But I could just take 4 of from 0 to pi over 2 inside of this one. So it's 1/2, remember polar area is 1/2 integral r squared d theta. So I think we hit it right on the head there. That's not the only way you could do it. I got kind of lucky that I spotted the right or the same way that they did it, because really the area would be this, and then you'd be going from from pi over 2 to pi, you'd be inside this curve, and then also from, I guess, from pi over 2 to 3 pi over 2, you'd be inside of this one, and then back to being inside the other one. But it's symmetric, and it's just 4 of these half peanut things. So that's this. Important thing you need to know is that area for polar is equal to 1/2 r squared d theta from whatever to whatever. And that from the whatever to whatever, you have to look out in these sort of radial lines from the origin to figure out where you're going to and what your limits of integration, like from 0 to pi over 2, is the directions that got us that. Number 26, table above gives values of the continuous function f at selected values of x. Notice that they did not say differentiable, so if f has exactly 2 critical points, critical point is either the derivative is 0 or undefined. On that interval, which of the following must be true? Okay, they're critical points. That does not necessarily mean that they're maximums and minimums. And but it does say that it's continuous. Okay, so maybe they do have to be, let's see. Well, let's take a look at the values here. So what it looks like it's happening, it looks like it's going down, and then up, and then up, and then down again. But it can do who knows what in between those. So we can't assume too much. Does f prime of x have to be greater than 0 for all x if there are exactly 2 critical points? Let's see. Oh, that could, let's see. No, because it could go from 5, like way down before it comes back up again. So you could still just have the 2 critical points, and this just goes way down into the negatives. Not that that's that far, and it could still have those 2 critical points. So that does not have to be true. Does f prime of x have to exist for all x? No. They only said it's continuous, not differentiable. And 2 critical points, those are places where it could be undefined. Right? So we don't know anything about that, the smoothness of it. Does f prime of x have to be less than 0 for all x in the open interval from 10 to 11? Actually, I think we kind of covered that already, that it could go like way down and then come up before it gets to the 2. So we already know that that doesn't have to be true. F prime of 12 can't be 0. I think that that has to be true because it looks like we have to have, if we're going from 5 to 2 to 3, there's got to be a minimum somewhere in there. And then 3 to 6 to 5, there's got to be a maximum somewhere in there. So this can't be another critical point. All right, that would be a 3rd critical point if f prime of 12 was equal to 0. So which of the following must be true? Hold on. So, oh yeah, because it's not equal to 0. Sorry, I got mixed up there. Yeah, so it cannot be equal to 0, so that must be true. Yep. All good. Ooh, slope fields. All right, so let g be a function such that g of y is greater than 0 for all y. Okay, so g of y is always positive. Which of the following could be a slope field for this differential equation? So g of y is greater than 0 for all y. So that just means that this is always positive, right? So I guess we're just looking for the slope field that does this. So this is a slope field. If you look at x equals plus or minus 1 for those x values, we would have horizontal lines, right? Because regardless of what the y value is, if x is equal to 1 or negative 1, we would have 0 slope. So that looks like it's true in A and B, but not true. This is like it's got them the wrong way. Alright, so those can't be true. That'd be like if it was y squared minus 1, then you'd get those. But all the x values, x could be 1 and y could be anything, so we get these stacked up horizontals. And then I just think we have to figure out what's happening in between. Let's just try when x is equal to 0, then that's going to be negative 1 times whatever g of y is. So that's always positive, so that's got to be negatives when x is 0. So it looks like A is the correct slope field. All right, what are all the values of p for which this converges? Well, these things, these improper integrals, are just like series. It's just like p series. The integral test and what we know about the harmonic series and p series, those things are directly connected to each other. So this is going to converge just like with series when 3p plus 1 is greater than 1. If this exponent right here is greater than 1, this integral is going to converge. If it's equal to 1, then you've got like a harmonic series kind of situation. And if it's less than 1, then no chance. So that means that 3p subtract 1 has to be greater than 0, so p has to be greater than 0. So that should be answer choice C. The temperature of a solid at time t greater than or equal to 0 is modeled by the non-constant function h and increases according to the differential equation this, where h of t is measured in degrees Fahrenheit and t is measured in hours. Which of the following must be true? Well, it looks like these are solutions to this, so I guess we should do that. So let's see. That whole thing would have to go over to the other side. 1 over 2h plus 1 dh is equal to dt. So here, taking the antiderivatives, of both sides, that would give me natural log of 2h plus 1, and I'd have to put a 1/2 out there because of that. If you think about how the chain rule works, should be pretty comfortable with that at this point. So if I multiply both sides by by 2 rather, haven't solved for C yet, so it's just some other constant. It looks like D would have to be true. Could solve that, right? It could go further, but that's where I'm going to stop because that matches up to one of their answers. And the last one. If the power series this converges at x equals 7 and diverges at x equals 9, which of the following must be true? Okay, so what we need to recognize here is that this is a series that is centered at 4. That is the center of this series. Now it converges at x equals 7, and it diverges at x equals 9. So the radius of convergence here could possibly be 5, but it can't be bigger than that. Like 9 could be an end point, and it could be like the first thing we run into that diverges. And this thing has to be symmetrical, so that must mean it would have to converge at 1, and then at 11, where did I get that? Minus negative 1. It could possibly converge, or maybe not. If 9 was one of the endpoints, 5 up from 4, then negative 1 would be the other endpoint. And you know when we check endpoints, you can get convergence at one and not the other. So that's possible. We just can't say about that. So all we can say for sure is it's got to, and this could be, the 9 could be like way outside the interval also. It could be as small as this. And actually, that would be a question mark too, at 1, whether it converges or not. Oh, and that's one of the things here, right? Because 7 could possibly be an endpoint, and then 1, the other endpoint, maybe, maybe not. We don't have enough information to know that. So, does this have to be true? No. Could it be true? Yeah. Could be. But we're looking for things that have to be true. Does the series have to converge at 2? Yes, because 7 is at the furthest possible situation. It could be the endpoint here, and 2 is still inside that interval. So that has to be true. Does the series have to diverge at x equals negative 1? No, because 9 could be this endpoint, and this could be the other one, and it could converge there. So it looks like only 2. That is a little bit tricky, I think.